Chances are you're using a computer to watch this right now. We use them every single day. But the core idea of what a computer actually is, well, it's surprisingly deep and has a pretty wild history. So let's dive in.
I mean, look at these things. You've got these gigantic room-sized behemoths from back in the day, and then you've got the supercomputer that you casually slip into your pocket. They're all called computers, but what's the common thread? What really makes a computer a computer? To figure that out, we have to start with the word itself.
Okay, so to really get to the heart of this, we've got to look at the word itself. And you might be surprised to hear that its meaning today totally different from what it used to be for like most of its existence.
All right, here's the official modern definition. The magic word here, the one you really got to pay attention to, is programmed. See, a computer isn't just a fancy calculator. Its real power, its secret sauce, is that you can give it a list of instructions, a program, and it will just run them automatically.
But, and this is the crazy part, that's a new thing. For hundreds of years, the word computer had absolutely nothing to do with a machine.
Yeah, you heard me right. The very first computers were people. It was literally a job title. A computer was someone, often a woman, whose job it was to just sit there all day and perform complex calculations by hand. They powered the massive science and engineering projects of the early 20th century. And get this, the Oxford English Dictionary tracks the word all the way back to 1613, and it's used to describe a person, the truest computer of times. It took literally centuries for that word to mean a machine instead of a person.
So what happened? What was the big idea, the total game changer that flipped that meaning on its head? Well, it all boils down to one simple, absolutely brilliant concept that separates your phone from a basic calculator: the stored program revolution.
Okay, so think about it like this. Early machines were fixed program. A pocket calculator is a perfect example. It's hardwired to do one thing, math. It can't suddenly decide to become a photo editor. But a stored program computer, it's like a shapeshifter. You load up a new program, new instructions into its memory, and poof, it becomes a word processor, or a web browser, or a game console. It can be anything. And that's the absolute key takeaway. The big idea is that the program, that list of instructions, is stored in the computer's memory right alongside the data it's working on. They're both just stuff in memory. This was the genius insight from Alan Turing way back in 1936, years before anyone could actually build a machine that did this.
And here it is, the moment that idea leaped off the page and into reality. This incredible contraption, nicknamed the Manchester Baby, fired up its first program on June 21, 1948. That was it. The first time a machine ever ran a program from its own electronic memory. The computer as we know it was born right there.
So once they had this amazing idea working, the engineers had a big question to answer. How should we set this up? How do we organize this memory that's holding both our program and our data? And that question basically split the design philosophy into two main camps, or what we call architectures.
Okay, so on the left, you've got the von Neumann architecture, and on the right, Harvard. Now, they look pretty similar, right? But there's one tiny but super important difference in how that CPU talks to the memory.
Let's break it down. The von Neumann way, which is what your laptop or phone probably uses, is like having one big library for everything, your instruction books and your data files. And there's only one main hallway or bus to get to all of it. It's simpler. Now, the Harvard architecture is like having two separate libraries, one just for instructions and one just for data, each with its own private hallway. This means you can grab an instruction and a piece of data at the exact same time, which can make things faster for certain jobs.
All right, so we've got the big ideas down. But that doesn't explain how we went from a machine the size of a small house to something you can lose in your couch cushions. That story is all about one thing: shrinking.
And this great shrinking basically happened in three massive jumps, three huge technological leaps. We went from giant, glowing vacuum tubes to tiny little transistors, and then to circuits so small you need a microscope to see them.
You want to talk about first-gen computers? Let's talk about ENIAC. This thing was a monster. It had thousands of these big, fragile glass vacuum tubes acting as switches. It weighed 30 tons, sucked up a crazy amount of electricity, and was constantly breaking down. Just a hot, unreliable giant.
Then, in 1947, Bell Labs invents the transistor, and it changes everything. This tiny little thing could do the exact same job as a big, clunky vacuum tube, but it was way smaller, way faster, used hardly any power, and almost never failed. This was the spark that ignited the second generation of computers.
And the third leap? The integrated circuit, the IC. This was pure genius. Instead of soldering individual transistors onto a board, engineers figured out how to basically print an entire circuit, thousands of transistors and all the connections, onto one little sliver of silicon. This gave us the microprocessor, a whole CPU on a single chip, and that is what kicked off the personal computer revolution in the 70s.
So, while we're on the topic of how these things work, or, sometimes don't work, have you ever wondered why we call a glitch in a computer a bug?
Well, it's because the first computer bug was an actual bug. A moth, to be exact. Back in 1947, the team running the Harvard Mark II couldn't figure out why it was malfunctioning. They opened it up and found a moth trapped in one of the relays. They pulled it out, taped it into the logbook with the note, "First actual case of bug being found." And the name just stuck. How cool is that?
Okay, fun stories aside, so how do all these pieces, the stored program idea, the transistor, the integrated circuit, how do they all come together to create the amazing devices we have in our hands today?
Well, it all leads to this little marvel, the System on a Chip, or SoC. And this isn't just a CPU, this is a whole computer. We're talking CPU, memory, graphics, the whole shebang, all crammed onto one single chip smaller than a coin. This is the powerhouse inside your smartphone.
So, just how many transistors can we cram onto one of these things now? Remember ENIAC with its thousands of vacuum tubes? Well, today, on a single chip, we're not talking thousands, not even millions. We're talking billions, with a B.
So there you have it. The computer went from being a person's job title to a revolutionary concept to a device with billions of microscopic switches that lives in your pocket. It's an absolutely incredible journey. And the wild part is, those core ideas, the ones figured out over 75 years ago, are still what make our entire digital world tick. Which really makes you wonder, what's the next big idea? What comes next?